Hello everyone, how are you all? I hope you all are doing very good. In today's class, what we are going to study is how to draw the ray diagrams of myopia and hypermetropia perfectly with measurements. Okay, so to do that, first take a straight line of 9 centimeters. Okay, first take a straight line of 9 centimeters like this. Now take a compass and keep the radius as 2.5 centimeters. See, 2.5 centimeters. Okay. Now you take from here 2.5 centimeters as radius and you construct a circle here. Okay, na? First you construct a circle here. After constructing a circle on this straight line, mark a point from this point, from the point here, from this point, mark a point 1 centimeter this side and 1 centimeter this side. Okay, now you take your eraser and erase this part. This is 1 centimeter is there, right? This point you keep here like this, and you erase this part. This part you erase. Okay, now after this, just you can change the orientation of your page like this, and this one you give the edges sharp, and 1 centimeter one more point you kept here, correct? This one you just join like this, and this one also we can just join like this. Smooth curve. Okay, this is the main part. After this, remaining parts will be a bit easier only. So now from here, this point is there, right? Here itself, this point and this point where you erased, there itself a bit below, and from here a bit above, you mark 2 points, and here you draw the lens, crystalline lens, which we are going to use as crystalline lens, this one. Okay, first diagram of myopia. Still what is remaining? Now this line you make it thick and extend this line to 2 centimeters more. This is going to be the object, and from here equidistant above 1 point you keep, take this, see, around from here just above 0.75 centimeters and below 0.75 centimeters, keep 2 points, and from this point you join these lines now, and this point also you join this line. Okay, and from here again you can join this line like this. This is going to be your myopia first ray diagram. These all will be the light rays, and after refraction one more time you give the light arrow marks. This one will be the object. Okay, now let us go to the second diagram. Here also you take a straight line of length 9 centimeters or somewhere around right? Now again try to draw the circle, taking 2.5 centimeters as radius. This is going to be our eyeball. And now from here 1 centimeter below and 1 centimeter in front, mark 2 points, take the eraser and erase this point now. Now you can take scale and make these edges sharp. Just change the orientation for your smooth operation. Now you can connect this to this point and this one also to this point. Smoothly you can connect. Okay, now make the straight line come like this. This is going to be our myopic secondary diagram, where we erased these 2 points, keep these 2 points here, and from here a bit above 0.5 and a bit below 0.5. okay, and from here to here you can have a convex lens. This is going to be our convex lens or crystalline lens. Okay, now next, secondary diagram, what it includes, it will be including only the parallel light rays. Okay, from here just above 0.75, 0.5, 0.75, and from here 0.5, 0.75 here. Keep and take straight lines now. And here also take straight lines, and here will be the object now. Somewhere here will be the object, and these light rays will be coming from infinity. There will be so many things to be learnt from ray diagrams, why we drew dotted lines, everything. When we draw dotted lines, it means that object is placed at infinity. Here nearby, myopia means what? Near-sightedness. Object is placed nearby, he is able to see clearly. Now it is starting with dotted lines means object is at infinity, object is placed at infinity. So now the image should not be formed on the retina. Image will be formed somewhere here. Okay na? This one will be the image formation. Okay. Next, third ray diagram. Now what happens? These light rays are getting converged at a point very nearby. We have to make these light rays converge on the retina. To make them converge on the retina, we have to introduce some diverging nature into this lens. Correct? To introduce some diverging nature, we have to keep one diverging lens here. Which is diverging lens? It is concave lens. Correct? So we are going to place one concave lens here in front of the eye. Okay. So third diagram, take the straight line first of all of length 9 to 10 centimeters, and now take a compass and keep the radius, take the radius as 2.5 centimeters, and now you complete the circle. Take the scale, exactly 1 centimeter below and 1 centimeter behind you, 1 centimeter ahead and 1 centimeter in front. Mark 2 points, and at this point you keep your scale and erase this part. You can change the orientation for your comfort, and you can join this to this point, correct? To join this to this point like this, and this one also to this point. So this is going to be our eyeball for the third ray diagram. Okay, so here what do we need to do? We need to have, first let us take lens here. This is the point and this is the point, and from here to here, somewhere here, a bit above, somewhere here. Draw the lens first here. After drawing the lens, we have to take one concave lens here now in front. Here let us take one concave lens. How to take one concave lens? First draw a straight line like this. Measure this line also. Above around 1.5 centimeters, below also around 1.5 centimeters. Now you draw a straight line horizontally also. Horizontal straight line also you take. Now you join these two lines. If you go on taking the measurements for lens also, it will take so much time. That's why you can just take this small concave lens which is there. This one you can draw at a free hand. Now what is remaining? Now take the light rays from infinity. If they are coming also, they have to meet on the retina. If they are coming from the nearby distance also, they should meet on retina. Take the light rays coming from infinity, which are coming from infinity, they should be passing through the lens, and after passing through the lens, then they have to a bit diverge. See, this is the straight point. A bit diverge you take, a bit diverging like this. This is a straight, correct? A bit diverging down, like this you take. Afterwards, they have to go and converge on the retina perfectly. On the retina perfectly, like this. Okay, now diverging nature should be clearly mentioned here. The light ray should be diverging. Diverging nature should be clearly seen. Okay. And now if the light rays are coming from nearby distance, object will be here. Somewhere object is here. Then also image should be formed on the retina only. So we have to join this light rays also here. Means after giving the concave lens, person is able to see if the object is placed at infinity also, and also the nearby distance. This is the meaning of these dotted lines. Okay. So this is going to be the ray diagram of myopia. Here arrow marks. Arrow marks are very important. Now let us draw the diagram of hypermetropia. Now let us draw the ray diagrams of hypermetropia. What is hypermetropia? Hypermetropia means long-sightedness, correct? So the person suffering with hypermetropia will be able to see things which are placed far away. But when you place the object near point, at the near point, he will not be able to see. Imagine that this is the normal near point, means 25 centimeters. From eye to 25 centimeters, near point will be there, right? This is the near point. For the person suffering with hypermetropia, near point will not be at 25 centimeters. He will not be able to see things which are placed nearby. But you should place a bit too far away, correct? If you place a bit too far away, what happens? That person's he will be able to see clearly. So if the light rays are coming from this point, then he will be able to see clearly. He will be able to see clearly means what? Image will be formed on the retina. Okay, na? So now see, this is the first ray diagram for hypermetropia. See, When the light rays are coming from a point which is far away from the near point, he is able to see clearly. Means image is formed on the retina. Imagine that the light rays comes from the near point, right? So here is the near point, correct? Suppose the light rays comes from the near point, means the object is placed at the near point only. Means object is placed at 25 centimeters perfectly. When the object is placed at 25 centimeters, what happens? He will not be able to see clearly. Correct? As he is not able to see clearly. Why he is not able to see clearly? Because image will not be formed on the retina now. Image will be formed a bit far away behind the retina. Somewhere here. Like this. Now what happened? The refracted light rays are meeting behind the retina. We have to introduce some converging property into these light rays, correct? To introduce some converging property, what we have to place? We have to place a lens here. Which type of lens we have to place here? We have to place a concave lens around 1.5 centimeters, right? We have to place one convex lens here, 1.5, yes, convex lens here, right? So if I place one convex lens here, then this lens will introduce the required converging nature into the light rays. After placing this convex lens, now if the light rays are coming from the near point also, suppose this is the near point of the eye, means 25 centimeters. What happens? From this, the light rays should be going like this. Light rays are going like this, but this converging lens will introduce some converging nature. Actually they should go like this, but they will converge and they will meet this lens now. See, some converging nature introduced. This should go like this, correct? But they are meeting here, means some converging nature introduced. After refraction from the crystalline lens or eye lens, they will go and exactly meet on the retina. If they are meeting on the retina, it means that image is formed on the retina. If the image is formed on the retina, it means that he is able to see clearly. Suppose the light rays comes from far away point also. From here also if light rays comes, these light rays also will meet the retina perfectly. This is n and this is only n dash. This is n. So this is how you need to draw the ray diagrams. Now how to draw ray diagrams we understood, right? Let us try to understand the ray diagrams now one more time. See here, see hypermetropia. Hypermetropia means long-sightedness. Long-sightedness means person will be able to see from far away, but he will not be able to see from nearby. This is the near point. Near point means from here to here 25 centimeters will be there. So when the object is placed at 25 centimeters, he is unable to see and the image is formed behind the retina. But if the object is placed a bit far away from the near point, he is able to see clearly. So what do we need to do now? We need to converge these light rays such a way that they will converge on the retina. Which is converging lens? Converging lens is convex lens. So we placed a convex lens of suitable power. What is the meaning of the suitable power? Suitable power means if these are meeting very far, then more converging nature needs to be introduced. If they are meeting here only, less converging nature introduced also sufficient to make them meet on the retina. So depending upon this distance where they are meeting, we will decide the power of this lens. How much converging nature needs to be introduced, that one depends the power of the lens. So to make the light rays converge, we used a convex lens and the light rays are meeting on the retina. Now understand myopia. What is myopia? Myopia means near-sightedness. Correct? So when the object is placed nearby, image is formed on the retina. Means light rays are coming from this point only. Now see the second ray diagram. Light rays are coming from infinity. Means object is placed far away. then light rays are getting converged in front of the retina only, means image is not formed on the retina. Whether the image is formed in front of retina or behind the retina, the person will not be able to see things clearly. So now what we have to do, we have to introduce some diverging nature to this light rays. Which lens introduces diverging nature? Concave lens. So we have to use a concave lens of suitable power to make these light rays go and meet on the retina perfectly. Okay na? So this is about the myopia and hypermetropia ray diagrams. In the next class we will solve some problems on myopia and hypermetropia. Okay? Thank you so much. We'll meet in the next video. Keep learning. Thank you.